Hello, my name is Andres Chalela, and this is the user guide video for the CodeVR 1.0 project. The CodeVR 1.0 group was composed by Miguel Jardines, Ralph Kinder, and myself. I will be presenting the different features that were implemented by the team during the current iteration of the project. CodeVR 1.0 is a proof of concept project sponsored by the FIU OpenHID Lab, and our group was able to implement several features that the long-term solution hopes to provide. CodeVR hopes to provide a 3D interactive visual representation of programming and computer science concepts. As such, this release of the project features an animated version of Quicksort and BubbleSort that a user can launch to get a better understanding of the algorithms. Although the implemented sorting animations have not been integrated into the main CodeVR Unreal application, future releases can integrate an animation section which would allow the viewing and interaction of different algorithms. A user can launch the CodeVR application by opening the project in the Unreal Engine 4 environment and clicking play on the top right of the screen. Once CodeVR is loaded, the user can walk around and press F on the keyboard to grab 3D objects and press F again to drop the objects. Relationships between objects are currently shown as connecting lines as shown here between the two spheres. A user can press P on the keyboard to see the environment menu, and if pressed again, the user is taken back to the virtual environment. If the main menu is clicked on, the user will be taken to the CodeVR main menu where they have the options for rendering, selecting a Python file, viewing options, and quitting the application. The option page gives the user the functionality of changing the screen resolution of the application. To use the render option, the user first has to click on the Select a Python File button, which will display a list of available pre-made Python source code files. Once a file is selected, the user can go back and click on the render button to generate a visual representation of the Python file in the 3D environment. Once all the objects are rendered and loaded, the user can now interact with them in the CodeVR environment. The CodeVR 1.0 project also features its custom implemented domain-specific language and source-to-source compiler. The domain-specific CodeVR language textually represents the generated source code via the 3D objects that a user creates within the virtual environment. The source-to-source compiler handles the export and import of source code and is composed of a language recognizer and a language application. The compiler was created using Java and the Antler 4 framework. The current iteration of the compiler defines the CodeVR language tokens and syntax via the implemented Antler, Lexer, and parser grammar rules and features the translation of CodeVR source code into the Python programming language. The compiler uses defined rules and the language recognizer to generate a valid parse tree from the provided CodeVR source code input. Once the parse tree is generated, the CodeVR language application traverses the tree and generates the translated language that is selected by the user. I will now guide you through the different parts that compose the CodeVR source-to-source compiler. Here you can see the Lexer grammar file that defines the Lexer rules that the language currently supports. These rules can be expanded on in future iterations to add more symbols, characters, and keywords to the CodeVR language. Here you can see the parser grammar rules that the CodeVR language currently supports. These rules define the structure of the syntax for the CodeVR language. They can also be expanded on in the future to include more programming concepts, such as loops, if statements, and classes. From these two grammar files, the Antler 4 framework generates the needed classes for the creation of a parse tree. I can demo a visual representation of a created parse tree by using the generated Lexer and parser classes and passing a CodeVR source code input into Antler 4's built-in testing rig. Once the parse tree is created, it has to be passed into the CodeVR language application for translation into Python. The translation is done by using a parse tree listener, which traverses the entire parse tree and triggers code whenever a specific parse tree node is visited. The class which handles the translation in the project is called CodeVR to Python. Here I will demo the execution of the CodeVR to Python language application, passing CodeVR source code as input. As you can see here, the language application generates a translated Python source code file, which represents the CodeVR input which was passed into the language application. Although this release of the project does not currently integrate the back-end source-to-source compiler with the Unreal Engine Visual Project, the groundwork has been put in place for future iterations to introduce such a feature to CodeVR. That sums up the user guide video for CodeVR 1.0. Thank you for watching.